Hello, I'm going to be trying something a little bit different in addition to just their normal notes recordings of just doing kind of like an overview, a quick topic thing. So I'm going to be recording at the board for this. We're going to test it out, see how it goes. So arc length, we have two different ways of solving it that I introduced in the notes. And of course, whichever you prefer is totally up to you. But we have the formula and we have the proportion. Let's back up a step. What is arc length? Let's answer that question first. So we know circumference is the measure all the way around a circle. If I wanted to know the circumference of circle O, I would take that radius of 5 inches and I would multiply using our formula 2 pi r. So that would be a radius, or a circumference of 10 pi, which is about 31.4, in this case, inches. But what if I only need to know a piece of the circumference, just a fractional portion of that circle? Well, that would be arc length. The length of an arc is a length of the piece of the circumference. In this case, the portion is making up an angle of 60 degrees in the circle. That's 60 degrees out of a total of 360. That means that we can set up a proportional relationship between the part to the whole, the part of the central angle to the whole circle, and the part of the arc to the whole circumference, which is where the proportion is born. But the formula is actually representing the exact same thing. So if we look over here, we have the proportion, rather the ratio, my bad. Man, I trip up on my words a lot. That's okay. The ratio of the degree of the arc to the total circle 360. And so that's like the fraction of how much we're working with times the total circumference. So if we think about it in a simpler way, if I said that the total circumference of a circle is 10 inches flat, what would half that circle be? Well, you go, well, half of 10 is 5. It would be an arc length of 5. It's the same concept here, except we're using kind of usually fractions that aren't as nice as 1/2. We have to use some random amount out of 360. Sometimes they're nice, sometimes they're not. But anyway, so if I'm working through this problem that I have here using this formula, I'm going to plug in the degree of my arc here. So if it was 60 degrees for the central angle, the arc is also 60 degrees. That's part of what we covered last Thursday. And I put that over 360. So here's the fractional portion of the circle we're working with. We need to also find our circumference. We have to put a formula in a formula. 2 times pi times 5, which again I mentioned is 10 pi. Here I went ahead and simplified the fraction so you guys could see it a little bit easier. So this is 1/6 of the circle out of a total 10 pi, meaning if we leave it in exact form, that's 5 over 3 pi for our circumference. Or if I want to know what that is in like numbers I can understand, that would be 5.24 inches out of a total, let's see, what was the total? 10 pi or 31.4 inches. And those numbers make sense to me. They don't seem unreasonable. 1/6 of 30 should be about 5. So these numbers are making sense to me. Now, what about the proportion thing? Because formulas in math, they're just sets of instructions. It's telling me what to plug in where and how to go through and solve it. So what about this proportion? Well, some people, they like things they're familiar with. And by this point in class, we should be well familiar with a proportion. We did it with similarity and a bunch of other different things. So we've studied it and we've used it before. So now I'm just applying it to a new context. The whole idea with proportions is doing the same relationship between your two ratios. So we have part over whole equals part over whole. Part of the circle out of the total 360, part of the circle out of the total circumference. So we have a very similar setup, but it's structured a little bit differently. 60 degrees out of my total 360 is equal to whatever my arc length is. I don't know, that's my x. out of 2 pi 5, 2 times pi times 5 for my total circumference. And with any proportion, we can cross multiply, so that would be what you do here. You can simplify along the way, like I simplified that to 10 pi. Once I cross multiply, I got 600 pi equals 360x. Divide by 360 and boom, we end up with the exact same answer, 5 over 3 pi or 5.24 inches. So again, whether you're more familiar with proportions and you want to keep using those, go for it. Or if that's just adding unnecessary stuff and you want to use the formula and just go straight forward, go for it. Math is all about finding your path to the answer. As long as you get there, you're all good. All right, so that sums up kind of just the breakdown between using the formula versus using a proportion to solve for arc length. And I hope that this is helpful. I'll see you guys next time.